All right, lesson 4.4, side angle side congruence theorems. So basically, this is a very nice lesson because it's all about shortcuts. It's all about making your life a little bit easier. So just to kind of highlight a couple things, scroll up here. In the previous section, in 4.3, if we wanted to, and I'm just going to kind of go off the grid for a quick second, if we wanted to prove that two triangles are congruent, all right, if you want to prove two triangles are congruent, what we had to do was we had to prove that all three angles and all three sides were congruent. So basically we needed 6 parts. We had to get everything. It's got to be an exact clone of itself, which in a proof is kind of difficult because that means you gotta come up with 6 different congruency statements throughout the proof. Well, it turns out that there are actually some shortcuts. You don't always need 6. Sometimes you only need 3, but if you can get the right 3. So we're going to be talking in the next couple of days about what the right 3 are and then what the wrong 3 are not. So hopefully that'll, and in our proofs we've been calling this the definition of congruent triangles at the very end. Once we get all 6 pieces, this was our reasoning. We're probably not going to be using that definition much anymore because we're not going to try to get all 6. We're going to do some shortcuts. So let's jump into the notes and see what those shortcuts are. So checking all 3 sides and all 3 angles to establish congruence can take a long time, and turns out isn't necessary. Alright, there are shortcuts to determine congruency. The first shortcut you're going to learn is called the Side-Side-Side Postulate, and normally we just refer to that as SSS, side-side-side. And basically it's a conditional statement. It's an if-then statement that said if 3 sides of one triangle are congruent to 3 sides of the other, then you can conclude the 2 triangles have to be congruent. So notice that we don't even need to know if the angles match up. Okay, there's no need to know that. If I give you 3 pieces of wood, let's say that I give you a board that's 3 feet long, and then I give you another board that's 5 feet long, and then I give you another board that's maybe, I don't know, let's just do 6 feet long. And I give you those 3 boards, and I say right now I want you to nail them together, nail them to form a triangle. And if everybody in this room did that and nailed them all together, if we brought them up and stacked them in the center of the room, every single triangle would land on top of the other ones and it would be a perfect match. Alright, so as long as all 3 sides match, the 2 triangles are congruent. So the key feature here is given 3 sets of congruent sides, you know that they are congruent. Now, sometimes you're explicitly given that, sometimes you got to kind of figure it out on your own. So let's look at example 1 here. Example 1 says, is it true that triangle KLM is congruent to NLM? Alright, KLM and NLM. Well, when I look at it, the first thing I notice is that KL should match up with NL. So KL matches up with NL, that's true. And then in my picture I have KM matching up with MN. So KM matches with MN. Well, you might say, well, wait a minute, I only have 2. Alright, so right now I'm given 2 sides congruent. So I might say, no, I don't have side, side, side. But if you look here, the way these triangles are positioned, they actually are shoved right up next to each other to where they share a side. Alright, and whenever they share a side, if I were to break these 2 triangles up and I were to draw the one on the left and then separate it and draw the one on the right, you would see that LM is part of both triangles. Okay, LM is a shared piece, so it's got to match up. Now when that happens, okay, in a proof, if something like this happens, you're going to say that this is called the reflexive property. The reflexive property, if you remember back from chapter 2, basically says that anything equals itself. So in a proof, I would say that LM is congruent to LM. So in a proof, that's how we're gonna write that. We're gonna write LM as congruent to itself, and that's always going to be the reflexive property. So this one is yes, they are congruent by side, 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 because I locked down 3 sides. So now you try the second one. Give this one a try, and I mean this one's pretty straightforward because we're given everything. I look over here to the right. Now I see that I do have 3 sides of one matching up with 3 sides of the other. So those 2 triangles are congruent. Now something I have to look at though is I have to make sure that the statement right here is in the correct order, because they may have screwed up the letters and the letters might not match up. But looking at these triangles, you know, side QT matches with TR. So QT matches with TR. That looks good. Let's check another side. It looks like SR should match PQ. So SR should match PQ. And once I've checked 2, the third one should take care of itself. PT should match ST. So PT, ST. The letters are in the correct position. So this is yes. Side, side, side. Alright, so side, side, side is pretty straightforward. It's pretty easy to see. This next one can be a little bit trickier. So before I jump into it, there is a word, if you look at the next proof, or the next theorem, which is called side angle side, the side angle side theorem, or postulate I should say. I guess it's not, technically not a theorem, it's a postulate. But anyway, if I notice it says if 2 sides, because I got 2 S's here, if 2 sides and the included angle, well, I got to talk about what an included angle is. So an included angle is the angle, I'm going to put it in quotes here, the angle between 2 sides, or whose sides of the angle are sides of the triangle. Now I think this is going to be easier with a picture. So say for instance I have a triangle. I have this triangle right here. And I want to focus on, let's say, I want to focus on this side and this side. So somehow I'm doing my proof and I can figure out that these 2 sides are congruent to another triangle, because that's how the proof sets out. It says if 2 sides are congruent to 2 sides. So let's say I have that. Well, the included angle, there's 3 angles in this triangle. There's one here, and one here. The included angle is the angle that touches or that shares those 2 sides. So this angle right here would be considered the included angle. These 2 down here, you know, this one and this one, these are the not included angles. At least when your perspective is coming from the red sides. So it's always the angle that touches the 2 sides that you know are congruent. That's a side angle side. So if we look at this example here, I'm given that BA is congruent to ED, and I'm given that AC is congruent to DF. It wouldn't do me any good to get angle B or angle C congruent, because the included angle for these 2 sides would be A, and over here it would be D. So if I can lock down that situation where I have 2 sides in the included angle, then I'm good to go. So it's very important, I want to highlight over here, it's very important that the A is between the 2 S's. There's a big difference from SAS and then what's considered SSA, or I always write it as A double crooked letter, because you'll remember that this is actually not one of the theorems. These guys don't work. It's got to be the angle in between the sides. And I'll go through and I'll explain this in class in a little bit more detail about why those other 2 don't work. So basically, if you're given 2 sides and the included angle, then you know the triangles are congruent. So this is shortcut number 2, SAS. Boom. All right, let's move on down and see if we can put some of this stuff into practice. So example 2, is the congruent statement true? Justify your answer. So I'm looking at these two triangles, and I have one set of sides, I have another set of sides. So I got my two sets of sides. I don't think there's any way to say that DE and AB are congruent to each other. I think that would just be speculation. So I'm not going to be able to use side, side, side on this one. But I do see an X. I do see some crossing lines. And I know that this angle right here and this angle right here have to be congruent to each other. Maybe I'll just call it angle 1 and angle 2. All right. So since angle 1 is congruent to angle 2 by vertical angles, okay, we have a vertical angle theorem that says 1 and 2 have to be equal. I've now fulfilled the postulate up above that I have a side, and I have this included angle in between, all right, on both triangles. So yes, the triangles are congruent by side angle side theorem. But I didn't have that, I wasn't given that until I came up with the vertical on my own. So let's look at part B. What about this one over here? Is it true that ABC and CDA? Well, one thing that catches my eyes right out of the gate here is I see some parallel lines. And right now, bells should be going off, man. Whenever you see parallel lines, you know in your little thought bubble over here, you know you're going to be doing something with alternate interior angles, because alternate interior angles are always congruent. So let's see what we got. Well, I know for sure that angle 1 has to be congruent to angle 2. All right, I know that for sure. Angle 1 is congruent to angle 2 by alternate interior angles. All right, so I've got the A locked down. I'm given that AB is congruent to CD or DC. Okay, that I was just given on the diagram. Well, man, right now I have an angle, I have a side, so I need to try to get another side somehow. And if I look at this picture, it looks like there's a shared side going on. Right here, side AC is congruent to itself. Okay, that's a reflexive property move. Reflexive property, AC, they share AC, so it's got to be the same. It's got to match up. So that's another side. Now when I look at it, I'm like, uh-oh, this doesn't look good. I got ASS, and up above I said ASS doesn't work. But now's where you really got to look at the picture and ask yourself, is the A the included angle? And I believe it is. You know, I have this side is a congruent side. This side is the other side that I know about. And the angle I have is that angle that's included. It is in between. So this is yes. The triangles are congruent by SAS. So I had to use a couple properties there, the reflexive and the alternate interior. Alright, moving right on down. Number 3. Are the triangles congruent? Why or why not? So let's look at these. I'm not going to write as much out on this one. But I see a set of sides. I see another set of sides. And I see a vertical angle. Since it is included, I have side angle side. So this is yes, side angle side. This one over here, it looks like I have an angle that matches up. And I have an angle, and I have an angle. Well, we do not have any theorem angle, angle, angle yet. So this is no. And we won't have an angle, angle, angle. And the reason being is you can have a small little triangle that might be 90 by 50 by 40. And then I may have a big, like his big brother chilling over here, that's a little bit bigger but similar, 50 and 40. Well, all their angles match up. All three angles match up. But clearly they're not congruent. This little guy right here is not the same size as that one. They're the same shape, but not the same size. They got to be clones of each other. So moral of the story is angle, angle, angle does not work. That's not going to be one of our shortcuts. So that's what I was talking about when I said you can only pick certain three-letter combinations. And right now we only have SSS and SAS. So over here on this last one, I believe this one is yes. I have two sides and then they share a side. So I have this little reflexive property going on here in the center. So this is yes, side, side, side. All right, example 4 down here at the bottom. Example 4, this is a little bit tougher. This one, basically, the idea is they give you two, so you're given two congruencies. They tell you the theorem that they want you to use, okay? So they're telling you, use side angle side, and they want you to tell them, well, what would I need? Well, what's the missing piece that would make it be side angle side? What's the piece that I need? So on this picture, it looks like I have a side matched up with a side. I have another side matched up with another side. So what additional information would I need? Well, if I'm going to use side angle side like they're telling me to, I need that angle, and I need the included angle. So I would have to have angle M is congruent to angle I. That would be the additional information needed to get side angle side. So that's your final answer right there. Those are the pieces that are needed. Now, if I need side, 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 well, on this one, I already have two sides. I have two sides for both, so I simply just need the third side. I would need to know that WY is congruent to FH. If I could get that extra piece, then I would have side, side, side. Now over here, how could I get side angle side? Well, I have a side and I have an angle, so I need a side. Now you got to be really careful on this one. I need a side, but one side will work and the other side won't work. So remember how this game goes. You have to have the included angle. So if this is my side and this is my angle, for this to be an included angle, the other side must be this one. So I know I need WV. UW up here would not have worked. I need WV. And I need WV to be congruent to who? Well, looking over in the other picture, I have the side, I have the angle, so this would be the included side. ZY. ZY. Now, if you were to put these other two sides, they would be wrong, because then it would not be side angle included side. It would be two sides and some random angle, which would be a double crooked letter. Doesn't work. Once in a great while it can, but only in certain situations. So, those are your notes today. Come in on Monday or Tuesday or whatever day it is, and get ready to rock and roll. See ya!